Okay, the lakes of the calamari. Now we're at results. So results is about one thing and only one thing: the outcome of the study. What did they find, right? So the primary measures. Did it support the hypothesis? The main things that they wanted to test it. Did it work out? Is there a difference where they expect the difference to be? Is there a correlation where they expect it to be? In the analysis, there are usually 3 different types of tests that you will encounter. And I will go and talk about each one in one slide in the next few pages. But I want to point them out because when we read results, and that even applies to psych majors, and when you look at results section, there are often a lot of stats, a lot of symbols, and if you are not a psych major or a science major who usually, we kind of like train you to read results, very often we treat it like diagrams in a regular textbook, right? So if you think about high school or other courses, right? If you have a textbook and there's a graph or a diagram, you usually feel that diagrams are just kind of like to break up the monotony and you skip it. Science articles are usually exactly the opposite. If it's not really, really, really important, they will never put it in the diagram. They would never put it in a table. So it's really actually important to look at the results. But the problem is that statistics is a field that is growing literally. Like every week they have some really new techniques coming out, and maybe some of you will get a stats minor and go to grad school doing stats. But there's a lot of new stats that come out all the time. And even if you do stats now as an undergrad, in 3 years time when you're in your first job and you read your papers, you might find that I have no idea what it is, never seen that before. But the nice thing about stats, even if you have not taken stats, is that they are usually categorizable into 3 main types. And I want to explain them to you to empower you to not need to skip the result sections in the future. Or not feel, like scared by it or overburdened by it. So there are 3 types of statistical analysis or 3 types of statistical questions. The first one is called descriptive stats or statistics. The second one is basically, I am asking about, are there relationships between variables, right? Relationship between variable type stats. And then the third kind is that I want to compare if groups are different. Comparison of means of different groups. And so let's go through all of them, and I'll use examples from the paper that we are reading to illustrate. So the first one, this is the descriptive stats. In the results, very early on in the paper, it described that when asked to compare the current experience, 9% reported increased discrimination, 41% increased anxiety, 53% increased depression, right? So in here, they are basically just painting the background for you, right? Describing what is. They're not saying that anxiety, the greater the anxiety, the greater the depression. If they said that, they're really like now relating different variables. They're not, right? They're just describing that, before the pandemic and now, just to give you a sense of, people are suffering. So this is descriptive statistics. Descriptive statistics could be percentages, could be means, could be counts as in frequencies. So it could be different presentations of a numerical value. But again, the goal there is not to test a hypothesis. The goal is not to answer a complex research question. The goal in descriptive statistics is to tell the story of what is, right? That's the narrative, the base of the narrative. And the next thing that we could do is the relationship between variables type of stats. And there are 2 main types that you will encounter, and you actually have both types in this paper. The first type is a correlation. You'll see people call it just correlation or bivariate correlation. Often you see people name it as a Pearson correlation, sometimes like the Spearman correlation. Again, the specific type of correlation, most people won't be able to distinguish unless you have taken some stats. And for those of you who have, I encourage you to go look at your notes. I'll definitely ask you in class at some point about the different types of correlations. But the main idea for those who haven't and might not be taking a lot of stats is that correlation shows whether variables are associated with each other. If you change one, does the other one predictably change? So for example, if I deprive your sleep, the lower your sleep number per night, the lower your test score will be on a computer task, right? Because you're sleepy, you can't pay attention. So the lower the sleep, the lower the test score, and therefore correspondingly, the higher your sleep, the higher your test score. That's a positive correlation, right? When one goes up, the other goes up. That's called positive correlation. The number will be somewhere between 0 and 1. 1 means maximally, perfectly, positively correlated with each other. 0 means that there's no correlation. You can sleep a lot, not sleep at all, and your computer task score doesn't change. So that's a positive correlation. A negative correlation would be when one score goes up, the other score goes down. So we might find that the higher your discrimination score, the lower your COVAC, the lower your the higher your discrimination score, the lower you feel about well-being, right? So that would be a negative correlation. So that's what we will look at when we look at an example of correlation. You might sometimes encounter regressions, and that is basically asking the question, can you use variable A that you measured to predict variable B? And bring back your high school math, right? Y equal to mx plus b. Basically, y is your outcome variable and x is your predictor variable. And you want to see, can you use x to predict y? Kind of like in a line, right? Oh, the higher the x, the higher the y. So that is a regression. Regression actually gives you the m's, as in that the one for every one extra unit of discrimination, you would feel a particular unit more of depression, right? So that is quantified for use in prediction. There are other forms of statistics that use these relationship between variable type stats. You might see people talk about hierarchical linear modeling, multi-level modeling. Whenever people use the word modeling, ultimately behind it are these relationship questions, right? Can A predict B, which in turn predicts C, but C is also predicted by A, and they draw a little like diagram with lots of line that looks like a spider web. At the very fundamental level, conceptually, is basically asking what's correlated with what, right? If I know one thing, one predictor, which other predictors go up, which other outcomes go up, and which ones go down, and how are they related to each other? So, so when you see modeling, don't shy away from it. It ultimately, at the background, is about these correlational relations. So it turns out that in this paper that you read, we have examples of both of these. So in table 1, it has correlations, right? These are bivariate correlations among key study variables. They also said descriptive statistics because they reported the mean and the standard deviation on the bottom, right? So the mean score for COVID impact was 61. The mean standard deviation for COVID impact was 14.84. So that's why they also called it descriptive statistics. But they, more importantly for us in this part of the lecture, they talked about this as bivariate correlation. So how do we read this graph, right? Again, don't skip tables. They're saying that factor 1, which is COVID impact is positively correlated with discrimination, as in the greater I feel that COVID has impacted negatively my life, the more I have also experienced discrimination, right? So that's a positive number. If I go down, this is another one, right? The higher COVID had impact on my life, the more anxious more anxiety I'm feeling. Same with depression, same with physical symptoms, and same with sleep, right? So that's definitely showing that documenting COVID impact seems to be predicting a lot of these psychological experiences. And now you might look at this table and say, okay, 1 is COVID impact, 2 is discrimination composite. 3 is social support. So I can go down 3. Social support is negatively correlated with anxiety in general, right? So the more social support, the less anxiety in general, the less depression in general, and less physical symptoms in general. I can see from these 3 numbers that the largest magnitude in these negative correlations is in depression, right? So social support seems to be most strongly correlated with decreasing depression symptoms, not so much decreasing anxiety and physical symptoms, but a little bit, right? So this is how you can go through and read these different correlations. You might, at this point, by the time you get to reading the table, have forgotten what are these things. You might be like, oh yeah, makes sense, makes a lot of sense. But then if you really ask yourself, wait a second, how do they measure anxiety? How do they define COVID impact? This is often when even I would go back to the method section and say, wait, let me remind myself, how do they measure? So in this case, is go back to page 72 and I can read that, okay, impact of COVID-19. This is, they developed a new scale that has how many items? I think 19 items, right? That they will say, this is not true of me at all, or very true of me, that I really felt these things happen, that has an impact on my life. So, okay, now I know how did they measure, how did they operationalize COVID symptoms. For those of you who have done research design, here is Cronbach's alpha, showing a high degree of reliability. So this is again the importance of reading the method section carefully and going back and forth between the method and the result section. It's totally fine. Everyone does it, to just go back and forth because we can't remember everything. So this is correlations. Now we also talked about the regression, right? So table 2 actually is the regression model. It tells me that they are predicting health outcome, right? So it just named it. Health outcome is the outcome variable, and therefore the predictor variables is discrimination, social support, and other covariates, other predictor variables. So we can see in here, these are the predictor variables and a whole bunch of numbers. So first thing is like, okay, what are they? Even if you have taken research design, most research design classes did not emphasize too much on regression. So this might be quite new to you. Let's move with me away from the table for a second and look at this. This is the regression model on the bottom. Regression model ultimately, again, remember, it's the same as your y equals to mx plus b. You're all graduated high school, so therefore you can do regression thinking. Even though you don't know how to click it on the software, you can learn it on YouTube. Everyone can learn everything on YouTube. But you know the basic reasoning, which is y, right, as in the outcome, equals to mx plus b, right? So mx is like the x, the variable. So what am I using to predict the outcome? Predictor 1, predictor 2, predictor 3, etc. You can put in 3, you can put in 20. There are again considerations for how many predictors you should put in given the sample size. But those are things that we talk about in the stats class. As a scientific reader, all you need to know is that, yep, I have a bunch of predictors. I want to know which predictor is important and which predictor is not important. Which predictor actually is a predictor. Which predictor is, I thought it was a predictor, but it's not, right? So that's the question that you're trying to answer. And this can be found in this table. In here, it actually presented 3 regression equations. I mean, three regression models, 3 regression analyses. In this first column, they use these 1, 2, 3, 4, 5 predictor variables to predict the outcome of anxiety. Done with it. Then they did a separate, point and click on the software and say, hey, now I don't want to predict anxiety. I want to predict depression. And they got the second column of data. Then they did the third one and the fourth one, etc. So let's take a look at anxiety together. What these numbers are, it explained in here, reported statistics of B and the standard error. Again, for those of you who haven't taken stats, standard error will not make sense to you, so I won't go into it in this class. But the B actually makes sense. The B is this, the slope, right? Is there a slope for each of the predictor? Because if a predictor makes no impact to the outcome, the B should be 0, which means that the predictor 1 score could be very low. It has 0, right? 0 translational impact on the outcome. If B is 0, predictor 1 could be very high. It still won't impact the outcome, right? So the closer the B is equal to 0, the smaller the outcome, the higher the B is different from 0, both in the positive realm and the negative realm, the more impact it has on the outcome. So given that, let's take a look at the anxiety regression model together and zoom into the screen if you need to. It's showing that, yep, there is a gender effect, and that is, remember, the alternative that they want to control for, that they know that people will say, well, did you check to see if there's a gender difference and account for it in your calculations? And they can say that, yep, we did. So we did factor it out and show that, yes, female participants did report a higher level of anxiety than male participants. So they definitely got that one in. And then they are still able, though, to say and we'll talk about this P equals to smaller than 0.01 in a few slides. But the idea in here is that there's a statistically significant effect of COVID-19 impact too, right? So COVID-19 impact being predicted to is not 0. The B is non-zero. That the higher the impact, because it's a positive number, the higher they report COVID-19 impact, the greater the level of anxiety. And if I go to the next predictor variable, which is predictor 3, in this case, discrimination, I also see a positive B, right? The greater of level of discrimination I feel, the higher my anxiety. Now the next one is social support. Social support didn't have a little star next to it, so it's not statistically significant, and they're using a more stringent level of 0.01 as rather than the conventional 0.05 as the statistical significance benchmark criteria. But they are basically saying that, look, social support, you might have more of it or less of it. The B, the slope, is practically 0. You can have more social support or less social support. After accounting for gender, impact, discrimination, social support per se doesn't seem to reduce or add to anxiety symptoms. So that's fairly interesting, right? Because when you look at regression model 2, social support seem to have a negative prediction to depression. So the greater the social support, the fewer the depressive symptoms the person experiences. So this is, therefore, now leave it to you. If you have not read the paper yet, you now go into reading the paper with more knowledge on how to read the table. If you have already read the paper and already annotated it, I ask you to please spend the 5 minutes, doesn't have to be more, go back to that page and take a look at the table and see if you can talk yourself through it, because that's a skill that you will carry forth beyond the course, right? In how to understand these multiple regression or modeling, statistical model outputs that you will encounter in a lot of research. Okay, the third kind, the final type of results is the comparisons of means type of stats, right? That I want to look at group 1's mean against group 2's mean. Are the means different? I'm not trying to see if you increase predictor 1 by a little bit, does the outcome also increase, right? Those belong to the previous type of question, the relationship between variables. Now I'm comparing different groups. And if you zoom in again, I know that this might be small on your screen, depending on what device you're watching this on. This is the graph that I mentioned about the pulse oximeter. So stick with me to watch to go through the graph together. Ultimately, the researchers are trying to compare the pulse ox rating for white patients and pulse ox readings for black patients. And what they are reading in here is plotted onto this axis is the arterial oxygen saturation. Okay, so this is what actually is in the blood, right? So when you measure the blood level, what is it? Over here on the y-axis is the oxygen saturation using the pulse ox little machine that you clip on your finger. So let's pick somebody who is at 90, right, which is not good at all. If you're at 90 pulse ox, right, the machine clipped onto, let's see, 178 white patients and 52 black patients who all have the pulse ox 90, they found that the mean for black patients is actually closer to, this looks more like an 86, 87. Even though the machine said that they were at 90, they really were dangerously low, right? Below 88, which is an emergency threshold. Whereas for the white patients, measuring pulse ox at 90, the arterial oxygen level is somewhere just below 90. So it's still overestimating by a little bit, but not as badly as for black patients, right? So we're comparing groups, comparing white patients to black patients, and the pulse ox level, the true oxygen level at every single level of pulse ox, right? And here you can see at every single, whether you are highly saturated at 96, we are actually overestimating using the pulse ox when it's for a black patient than for a white patient. And all the way through to people who are really low in the pulse ox reading, right? The finger clip. If the finger clip said that you're 89, yep, you are actually right at 89 if you are a white patient. Of course, there's variation in the accuracy. So there's a range of accuracy. But if you are a black patient, we can pretty much be for sure knowing that it is like grossly overestimating your pulse ox, and that you are definitely at an emergency level in terms of needing more oxygen support. So in this case, we're comparing groups, we're comparing means. So this is yet another type of analysis that you will encounter. So 3, just to recap: descriptive statistics, or relationship between variables types of statistics, or comparison of means type of statistics. Knowing that they either belong to one or the other should help you navigate most research papers, even if you're a novice in the field. So now one final little piece is that the little statistical significance in there, right? The star that we saw, that it says P is smaller than 0.01 or P smaller than 0.05. What is that P value? And even those of us who have taken research design sometimes forget. So the P value, standing for significance, is about the likelihood of a false positive finding if the truly did not exist in that pattern, right? So maybe there really isn't a correlation out there in the world, but because of the nature of my sampling and just, the people who were in my sample, because people are different one from another. Sometimes you can by chance, right? Just simply by chance find a pattern that is just noise and random. If you toss a coin 4 times in a row, it is possible that you get 4 heads in a row, right? So that's random. It doesn't mean that your coin is biased, right? It's just random. So the nature of randomness means that sometimes we will find a pattern even when there isn't. And so that's what the P value is. So when people write in reports, P smaller than 0.05, P smaller than 0.01, is basically using the mathematical assumptions. It is either less than 5% chance or less than 1% chance that I will find this pattern just by chance, if there wasn't something like that really out there. But that also means that therefore 1 in 20 P in 0.05 could possibly truly be by chance, right? So it's not foolproof. And that's why in psychological and research and a lot of empirical research, we value the practice of replication, right? So that's a little star you might want to put in your notebook. The key of replication. You might read a finding that is counterintuitive and you're like, wow, did they really find that? Well, is it because of their sample? Is it because they did it in North Dakota rather than in another part of the country? When you can put greater faith in those results when people have replicated it, maybe they actually have study 1, study 2, and study 3. If you toss a coin 4 times in a row, you might get 4 heads in one go. But when you do it a second time, it's unlikely that you'll get 4 heads in one row, right? So again, replication allows you to rule out those false positives. Replication in the same site, replication in different sites, different universities, and across different studies. So that is what the p-value is. Now, very important to remember is that statistical significance does not mean regular language significance or importance. Right? When we say significant other, that's an important other. But if it's a statistically significant other, that is not an important. It's just that I have no doubt that that person is Jamie. I'm very sure that it's Jamie. Doesn't mean that it's practically important. So statistical significance means that it is unlikely a false positive. But don't confound the lack of statistical significance with that it is not an important question, or vice versa, that you found something that is statistically significant and therefore it is ground changing and really important. Because they're just two different concepts. That they could be they could both be a yes, or one is a yes and one is a no, or they could both be no's, right? So they're just independent concepts, but often confounded when we are talking about research. And then the final piece when we talk about statistical significance is that maybe you look at the data and you say, oh yeah, the effect, right? Whether the person experienced more or less discrimination, change anxiety score by 0.21. That's not a lot, right? That's a small effect. But small effects could also be practically significant, because a small effect, a 0.2 score increase in level of anxiety every single day, 24 hours a day, 7 days a week, 365 days a year, that is somebody's quality of life, right? And that's somebody's well-being and their family's well-being. So even small differences could actually be practically significant. If you ever one day design a new therapy regime that can reduce depression suffering, again, we need to define how we measure it, by 3%. 3% is so small. 1% is so small. That's actually practically really significant, practically important, because 1% in people's well-being nationally, wow, think about that. If we can reduce violence by 1%, that's big. So when you think about results, yes, do think about the numbers, but don't let the actual number detract you from how the results then lead back to what the implications of the studies are. Which leads us to the final letter, the I of the QALMRI, which is inferences, right? What do the results tell you about, most proximally, the research project, as in the hypothesis, right? Did it support the hypothesis? Did it rule out the alternatives that we have set out to exclude, right? So that's definitely one of the first things. You usually will see that in the first 2 paragraphs of the discussion. They will summarize the study and say, did they find support or did they not find support? They will also, within the first page of the discussion, talk about potential limitations. What else do we need to do? What are the additional alternative hypotheses that we now need to roll out? What is future research? Usually often, I wouldn't say usually, I think it's often half and half, depends on the discipline. You will find that the researcher will then, towards the end of the discussion section, talk about also implications, right? So knowing what we know now, how does it inform practice? How do we design a new curriculum for students? How might we change teacher training? How might we change hiring and promotion processes? So those things also usually happen in the inferences. So you're done, and so you've done the QALMRI, and I hope that you will use the QALMRI to take notes in future papers. In class, I will often refer to the QALMRI method as we talk about research papers. So do definitely be ready to engage with this tasty calamari squid and vegan calamari also. That is made of in the design. It could be made of mushroom protein in addition to real protein. So that's our little creativity in the QALMRI. I look forward to seeing you in class.